Okay, well, good afternoon, everyone. Thanks for being here. My name is Adrien Depaillat, and today I'm going to talk about seawater air conditioning. So I'll start with a quick presentation of our company, and then I'll move on to the interaction between the Malaysian products and our studies. So, who are we? DeProfundis is a research department specialized in renewable energies, and more particularly in seawater air conditioning, thanks to the expertise of Bruno Garnier, who is one of its co-founders and who worked in the past for the Ifremer station of Tahiti. Back in 2011, it was decided upon a mutual interest from Électricité de France and DeProfundis to create a joint venture called DeProfundis Ingenium, which is entirely dedicated to the development of low-cost SWAC. So for the remaining time of the presentation, I'm going to say SWAC as the acronym for seawater air conditioning to save some time. So how does that work? I think the best thing to do is to get you through an example. So we are working on the seawater air conditioning project for the Reunion Island. On the southern part of the Reunion Island, you have a city called Saint-Pierre. And there is an hospital that we want to provide air conditioning with. So what we do is that we pump deep cold seawater over here. It's approximately 1,000 meters below the surface level. This cold water is then carried all the way through the building of the customer here. And through the use of heat exchangers, we transfer the cooling energy from the seawater loop to a secondary loop which runs through the building of the customer and which supplies it with air conditioning. The seawater is then released back at sea at approximately 200 meters below the surface to make sure that we do not disturb the photic zone, because the water that we pump is very rich in nutrients. So if you release that in a photic zone, that means if you release this water in an area where you have still decent amount of light coming from the sun, you may trigger a green bloom or which is a rapid growth of algae, and that would be detrimental to the environment, so we don't do that. And for information, these pipes are in high density polyethylene. It's a sort of plastic pipe. This is the kind of pipe that we use that you can use every day for drinkable water, for drinking water, for example. The most important advantage of that technology is that it allows you to save between 80 to 90% of the electricity that you would have required to produce the same cooling need with a regular cooling machine. And this is because a regular cooling machine is operating a compression cycle which is very energy consuming. And with the seawater air conditioning system, you still need some energy for the pumping system, but it's nothing compared to what you would need with a regular cooling system. So that's the first advantage. The second one is that it's an environment-friendly solution. Firstly, because you save energy, and secondly, because you don't need any CFC nor any refrigerant fluids, which are known to be harmful to both the humans and the environment. And lastly, the deep seawater is a cooling reservoir which is available 24/7, because I'm going to get back to this later, but if you go deep enough, you don't have any more variations of temperature due to when you are deep enough, there are no variations of the season with the seasons. So moving on to the products that we use essentially one product, which is the Global Ocean Physics Reanalysis 2v3. Well, starting next week, apparently it's going to be 2v4. And the two data sets that we use are the current velocity and the thermal gradients. And this one is by far the most important one that we need. So how do we get these? We have developed an Excel routine, so we have all the NC files of the model in our computers, and we have developed these routines, which they called an open source dynamic link library produced by Mr. Alexander Bruns. And thanks to this, we can extract all the data we need, and we can plot whatever we want, such as the monthly mean thermal gradient, as you can see there. So it goes to 2012 because it was done a couple of years ago. And well, as I said before, so you have the depth here and the temperature plotted here. If you go deeper than 150 meters, well, even 100 meters, you can see that you don't have any more variations of the temperature with the months. So this is why I said that the cooling reservoir at a depth of 1,000 meters is stable. You have an example of what we can extract from the velocity, and this is used for the design of the anchoring systems and the ballasts. And so why does the temperature matter so much? It's because, for example, if I take, again, the example of the project of Saint-Pierre, in blue you have the shape of the intake pipe, and red is the seabed, or the bathymetric profile, as we call it. And the intake pipe is approximately 8 kilometers long. So therefore, with an average water velocity of 2 meters per second, it takes more than an hour for the seawater to get from the intake point to the customer. More than an hour, that means that, well, it means that the heat transfer between the open ocean and the seawater which is being pumped through the intake pipe is nowhere close to being negligible, and we absolutely have to estimate it in the most accurate way. And this is where the Malaysian dataset, temperature dataset, comes into play. So thanks to this, we were able to, well, thanks to that and to other worldwide datasets such as the GEPCO, for example, which is the General Bathymetric Chart of the Oceans, and which is published by the NOAA, which is the American Institute, it's National Oceanic and Atmospheric Administration. We were able to survey the SWAC potential for more than 150 locations around the world. And more particularly, we were able to do a close study we have surveyed more than 1,000 kilometers of coasts within the several French overseas departments and regions. So for these, we use the bathymetry from the CHOM, the Service Hydrographique et Océanographique de la Marine. And this is really useful for our contractor, which is EDF, because we give them a map giving the potential for the SWAC potential, and on their side they are able to prospect and look for. They know that there is a potential for a SWAC, and that helps them to look for potential feasibility studies in terms of cooling districts. So, for example, this is something that happened for the Martinique. We spotted a interesting potential for a SWAC system close to the Shoalshire municipality, and EDF has mandated a local company to do energy auditing to see what kind of cooling need was present there, and they came back to us asking for a more detailed study to see for which cooling networks, how well would the SWAC perform with several sorts of cooling networks. So I wanted to compare so we've been talking about evaluating the accuracy of these data sets, and I had the chance to, for the SWAC project of Saint-Pierre, we had a measurement campaign done in January 2014, and I was able to extract the temperature gradient from the migration database on January the 14th as well. And so on the left axis you have the temperature plotted, so the black point, the black dotted line represents the migration dataset, and the colored dots are from the measurement campaign. And as you can see, the mean error is pretty low. It's plotted on the right axis, and it's less than 4 to 5%. And at the time I'm still not familiar with the downscaling, so I just picked the closest point I could find from the motion database, which is approximately 6 kilometers away from the point where the real measurements were made. We had another project ongoing for the air conditioning of the Ulumale airport in the Maldives, so I did the same thing. This time it was the measurement campaign was made by Hitachi in 2011. And so the error is a bit higher for the shallow depth, but there are several things that could explain part of the error. For example, the fact that the closest point I could find is more than 20 kilometers away from the measurement points. And so that could be one reason. And but I mean, it's still less than 10% or 11%. And if you go deeper than 200 meters, you are less than 6%, which is, to me, pretty good, considering that this is a model which is operating on the global scale around the whole, the 7 seas. I wanted to talk about the weaknesses, but it's really, I realize it's really not a weakness, but rather a misinterpretation of the results. I tried to do the same thing for another project that we have to cool down the tunnels of the Eurotunnel is using the skin friction between the trains of Eurotunnel are producing lots of heat, so they always have a need for cooling. And I've been looking at the temperature of the sea in this area, but I wasn't able to find a decent, I mean, like the Mauritian dataset is really not in agreement with the dataset that I got from the World Ocean Database, but there are many things I'd like to add. The fact that, first, this area is very shallow, so there may be, this is a place where I think downscaling could have a great impact. Secondly, the World Ocean Database, in this particular case, has some of its data points which are from the 18th century, so the accuracy may not be as precise as we want it to be. And lastly, I've read a study about the behavior of the English Channel, and it appears that depending on if you're looking at the eastern side or the western side, you can have both patterns of temperature. You can have either a flat pattern, which barely varies with the depth, even in summer days. But you can also have, if you're on the other side, this kind of pattern with a decreasing temperature with depth on summer days. So it's not really, I wouldn't call that a weakness, just rather a misinterpretation of the results. Now coming to what can we do to improve it, I'd say the access is already good through the use of FTP servers. The extraction is no longer a problem because of the Excel routine that we have developed. And so I'll just ask to keep updates going because the bug corrections are really important, and keep up the service user help because they are really efficient and quick to respond. And yeah, well, the only thing I could use is to know more about downscaling, but this issue is being addressed this week, so hopefully I'll know more by the end of the week about that perspective. So if you have any questions, feel free to ask me, and if you have questions later on, you can still email them to me. I'll try to get back to you as soon as I can, and you can send the questions in English or in French. I'll do whatever I can answer in whichever language you want. So thank you.